So we've kind of come with that mass manufacturing consumer background and said, how do we just make this industry more efficient and drive out cost and complexity at every piece of that value chain that we can? The successful EV manufacturers didn't just take an internal combustion car and put an electric motor in it and call it a day. They rethought the product with the new technology and software that was available to make the product experience better. We're trying to do the same thing for the home.
Hey there, welcome to another episode of the Climate Cycle, where we sit down with the founders, investors, and leaders building and deploying climate solutions right here in Canada. I'm your host, Justin Rice. If you've been following the home electrification space, you know there are a bunch of companies working to accelerate heat pump adoption. We know the technology works, it's been ready for decades, but actually getting it into homes has been a challenge. High upfront costs price people out, the buying process feels like it's stuck in the 90s, and the supply chain stacks layers of margin between the manufacturer and your home. Today's guest is Stephen Lake, the founder and CEO of Jetson, a home electrification company that's focused on making the transition to electric systems more affordable and sustainable. I wanted to talk to Stephen to understand why this gap between potential and adoption exists, and Jetson's thesis on how to close it. What really jumped out to me about Jetson is their vertically integrated approach. Most companies pick one piece to fix, the pricing, hardware, or streamlining rebates, but Jetson owns the full experience, from hardware through to installation, and they're leveraging data across the lifecycle to drive continuous improvement. In our conversation, we'll talk about why home heating matters as much, if not more, than other solutions like switching to an EV, how they think about entering new markets, the myths that are still slowing down adoption, and how they're applying a consumer products mindset to an industry that hasn't changed in decades. And now, my conversation with Stephen. Stephen, welcome to the show.
Great. Thanks for having me on, Justin. Appreciate it.
Yeah, really glad we could set this up. I've been following Jetson basically since the company started, so really interested to dive into this space. Heat pumps in particular seem like they're interesting. They're like a climate no-brainer to a certain degree, but also a sticky one to actually like go out and deploy and get into people's homes. So I'm looking forward to diving into all of that. But I'd love to really just start with a bit of your background. So you've been building hardware and hardware adjacent things for a really long time. You founded North, a wearables company that you sold to Google, now Jetson. What was the through line for you and how did you end up in this space?
Yeah, I've always been interested in this. You can bucket it as hardware, but really it's the intersection of software and how we technology interacts with our lives and kind of this fabric of technology that supports us throughout the day. So at my last business, which was North, originally called Thalmic Labs, that was all about wearable tech. Our first product was this armband product that actually picked up muscle activation. So the electrical impulses from your muscles to detect all of your hand gestures and motions, was initially conceived as this basically the mouse for AR and VR. So once we had headsets and goggles, how you would effectively interact with the content and world there. We later invented a technology for near eye displays and introduced a product called Focals, which was really the first consumer smart glass product. So these were prescription glasses that look just like regular glasses, but we're projecting essentially pixels directly on your retina with this holographic laser MEM scan technology. So a super deep tech company. We had our own manufacturing setup. We were developing our own chips, brand new material science to support that. Just really, really deep tech business. We sold that to Google in 2020. And along with the same founding team and a lot of other early team members, decided to start Jetson in a very different space. But the connection there was prior to selling North and following that sale, we really wanted to build something, our next business, in the energy transition, and had just for a long time been a big passion of my own and the rest of the team. And we were just constantly talking about how could we have the biggest impact on the energy transition, and kept coming back to the home as this sort of hugely impactful area that hadn't had as much attention, I think, as other parts of the energy transition. We think about electric vehicles as, consumers. We're now, for many of us, like 2 decades into that story, from like the earliest EVs and then Tesla and others, to a point where today we're kind of very clearly on a path where that's happening. Like there's tons of products out there. All the major manufacturers have adopted the technology. Numbers are increasing in the market. It's very clear we're kind of well on that journey. The home has has much of an emissions profile as that car in your driveway, but has had less attention. So in North
Right.
America, just the basic numbers is 22% of end energy use is residential use. So it's 22% of all energy of all types. That's oil and gas, electricity, et cetera, goes to the home. Of that, the majority, about 75%, is space and water heating. So and that's out to be about 15% of all energy in the US, and probably similar in Canada, is going to heating, cooling our homes. So just a
Right.
huge chunk. And that's like similar order of magnitude to transport. So if I think of car in the driveway, with we think of actively of like the emissions and the smog coming out of that tailpipe. Well, actually, your house has got similarly as much emissions coming out of the vent pipe for your furnace typically, or your water heater. So huge opportunity, and it's one where the technology to solve this has actually been around for a long time, and more than just how do we get homes off of fossil fuels and make them more um, you know less polluting. We've had technology for a long time that actually just makes it a better experience for the home. It's more comfortable, which we can talk about. Like there's a modern way that we can heat and cool our homes. It doesn't require piping in explosive flammable gas to our basement and like setting it on fire and burning
Yeah,
it,
yeah.
and all the byproducts of that just like flowing into the air in and around our homes. It's a little bit crazy to think that today, across North America, the vast majority, like 75% of homes, that's what we do.
Hmm.
Some cases we truck in a tank of oil and fill that up every couple of months. But for most of us, we pipe in literally explosive gas into our home and set it on fire.
Yeah.
And in the year, today, that's just so crazy. So that's the status quo. What we saw about the category and the opportunity was that the technology existed, but deployment was low. So as mentioned, 75% still burn fossil fuels. About 10% or so, maybe 12% have a heat pump system today, which is the clean, efficient, economical way to do this. The big challenge was twofold in getting more homeowners to convert over. One is that there's been a green premium
Right.
traditionally here. So that green premium in traditional numbers would be, let's say I just put in a new gas furnace and an air conditioner unit. That's something like $12,000 to $15,000 for reasonable efficiency equipment for a whole home replacement. You're usually looking at 25 to 30,000 average quotes for a whole home cold climate central heat pump system. So big green premium. Like for most homeowners off the bat, that's just not an option to spend that much more money on the better system. And then even if you got to the price point and said, okay, it's worth it for me. I want to upgrade my home and spend the full 25,000 versus 15, let's say. Then you have this really high friction process. So my background is in consumer products. We think about how easy it is today to buy a product, on Amazon or the best direct to consumer brands. If you go to the website, you buy the product, it's a great experience. It shows up, in a couple of days. It's really easy. In home services, that's just not where we are today. It's much more like the automotive industry before Tesla, right? Where you kind of would go
Okay.
to like that old Ford dealership and it wasn't clear what the real price was. You would negotiate it. You always felt like it was a bit of a very non-transparent interaction, let's say. And we think of that as like an old school interaction today. That's not what we expect now. When you buy a Rivian or a Tesla, you just go on the website and you buy it, or the app.
Yeah, yeah.
But the home's not like that. So the home today, you want to upgrade your heating system where it breaks down. You find a local technician, you call them, they come and look at it, maybe take some measurements. You're not maybe quite sure exactly like how fair the price you're getting might be. It's, basically a sale at your kitchen table. You go through this like good, better, best. You want the gold, platinum, or like super platinum, XYZ model. Once you get through that, you then have this complicated process to get permits in place, to figure out if there's rebates or incentives that might apply to your upgrade, which ones you get for all the paperwork. And it becomes this like fairly prolonged, essentially construction project that you're managing.
Right.
You
Yeah,
might need
yeah.
electrical upgrades, you might need a different contractor to do that. It's a whole thing. And so the core thesis for Jetson is we want to get millions of homes upgraded to better systems that are going to be saving money every month on their heating system, not emitting nearly or potentially no emissions whatsoever. Upgraded home, and make that as easy as buying your next favorite consumer product. So
Right.
that's the core model of Jetson. We make it dramatically less expensive typically to upgrade your home, and we make it really easy. A full online process. There's none of that in-home, in-person sales. It's all online like you'd expect today. The actual installation, we make it extremely streamlined. We have our own in-house crews that do this work. It's a single day install process. We've kind of come with that mass manufacturing consumer background and said, how do we just make this industry more efficient and drive out cost and complexity at every piece of that value chain that we can. So
Yeah.
that's essentially where Justin came from.
That's awesome. Yeah. And I like a lot there I want to unpack, and particularly that kind of vertically integrated thesis. As I was saying at the top, like this adoption gap to me has really always jumped out as like the problem to solve. And so I think this approach is super interesting. Before we jump into that, I think it might be helpful to kind of unpack the climate aspect of this a little bit more, though. So you talked a little bit about the amount of final energy use that home energy heating takes up. Can you just like put that into context in terms of like what that means for climate change, and like maybe how you kind of drill down into this problem?
Yeah, basically, your typical home is emitting somewhere from 1 to 2 cars worth of pollution every year.
Okay.
That's kind of the simple numbers to put in front of it. So if I think of the car in the driveway, maybe you replace that with an EV, your home is still emitting as much pollution as that car was out of the tailpipe every year. So every home we convert is like 1 to 2, in some areas, colder areas, 3 cars off the road annually. And the sort of net impact of that is massive. So in the best areas where your electricity grid is quite clean, it's can be 100% reduction. So here in British Columbia, we're 99% renewable generation. So that's like primarily hydropower. And essentially today, if you convert your home to a heat pump, there is zero emissions. Your electricity is generated from, rainfall and gravity and hydropower,
Yeah,
and that
yeah.
is heating and cooling your home. It is like amazing, zero emissions. But even in states and markets that still have some amount of fossil fuel electricity generation, so think of Colorado, which is about 50-50, about 50% no emissions generation and 50% still natural gas and even some coal, I believe. But even in that case, if you look at the net reduction in emissions, it's much more than that 50%, because the heat pump is far more efficient than the gas furnace. So a traditional gas or oil furnace is anywhere from 60% to 95% efficient. Like you get, for 1 kilowatt of input energy, you get, 0.4 to 0.95 kilowatts of heat in the home. The heat pump is dramatically more efficient. So for every 1 kilowatt of electricity, we're getting 3 to 4 kilowatts of heat output in the home, which is, I think, what a lot of people miss when thinking about this. The huge upside of this transition is with a heat pump, you're not creating that heat. So a heat pump is, I think maybe some folks have understood this, others don't, which is it's not creating the heat. So often we think about electric heat being
Right. Like a
like
baseboard or
inefficient, like
something.
baseboard heaters or something.
Yeah.
Those are resistive electric heaters. So those you get 1 kilowatt in of energy, 1 kilowatt of heat out, right? It's just heating up a wire and it's heating your house. A heat pump doesn't do that. So it's actually not using the electricity to create the heat. It's using it to move heat that already exists in the outside air into your home, or the opposite, to cool the home in the summer. And so what it's doing is basically you've got, just like your fridge is working, you have an outside unit. That outside unit, air is flowing through with a fan. Even when it's minus 30 out, there's still heat energy in the air all the way down to absolute zero. And the refrigerants in these units are engineered to basically boil at very low temperatures. So what they can do is pick up heat from the outside air. They move it through that refrigerant into the inside unit. Another fan is blowing air over coil inside where it's releasing the heat. So at the end of the day, I'm taking, like, again, 1 unit of electricity, I'm getting 3 units of heat in the home. So they're,
Right.
or 4 units of heat in the home. So they're much more efficient. And so when you do the math on all that and you say, okay, well, maybe your grid is still 50% fossil fuels and there's some losses from the transmission, but the heat pump is 3 to 4 times more efficient at the end home. Where that nets out is somewhere between a 70 to 80% reduction for most areas we're in emissions
Wow.
for that home when you net it all out. And that's today. In all of these areas, the grids are getting cleaner and cleaner.
Yeah.
So
Yeah.
it's like 70 to 80% reduction in emissions on day one. And then over time, that should approach 100% as we continue to build primarily new renewables as new power sources right now in the US and Canada.
Interesting. So it's not even just that that 20 odd percent of final energy use gets decarbonized. It's that might become significantly less overall use just because of that efficiency.
That's right. Yeah. So you're
Yeah.
using typically about a third of the overall energy when you switch to a heat pump.
Yeah.
So,
Yeah.
yeah.
That's wild. And I feel like that is maybe something that doesn't always make it through when people are hearing about heat pumps, like that efficiency edge. So I'd love to just unpack like what is Jetson today? Because I think, you go on the website, you see like the Jetson branded HVAC, there's the installation, but just talk to us a little bit about like what does the company actually do?
Yeah, it's a great question. I'll come back to that, but just on the
Yeah.
last point of efficiency, one more point, not to dwell on it too much, is that I think when a lot of people hear the efficiency numbers of heat pumps, they think it's like it's wrong or it's made up or something. Because we say,
Right.
hey, the unit is 350% efficient. That doesn't seem like a kind of, I think about your basic physics, like how can it be more than 100%? It doesn't seem possible. But and that's the magic of the technology, right? It's not, it couldn't be more than 100% if you were just consuming, energy to make heat, but you're actually just moving a heat that already exists. So that's how you
Right.
get these amazing efficiencies. I'm taking heat, it's already there. I'm just moving it inside or outside of the home. Yeah, and your question is, what is Jetson today? So
Hmm.
Jetson is a modern way to upgrade your home to a zero emissions, all electric system. We make it extremely easy. So it's a fully online process. You can go to our website, jetsonhome.com, if you're in one of our service areas. Right now, we're in BC, New York, Colorado, Massachusetts, and many more locations launching shortly. You enter your address, we look up the home, and we pull a whole ton of information about the home, the footprint, the way it's facing, the local temperatures where it is, the year it was built, the insulation values, all kinds of information from it, like far more than a normal in-home evaluation would ever look at when you have someone come into the home. We take all of that, we model the whole home. We do this detailed sort of building science model where we look at every hour of the year on historical extreme weather. So the hottest days in the summer, the coldest days in the winter, the right heat load that your home heat and cooling load your home would need. So how much energy does it, how much heat do you need to heat your home in the winter? How much cooling do you need in the summer? From that, we then automatically design a heat pump system for you. So using our Jetson Air system, we'll design the right system. We'll then go and check which rebates and incentives you may qualify for. So there's a huge set of those. It could be down to your utility, your municipality, your income level, how many people live in the house. There's sort of provincial, state, federal level rebates that are out there and incentives. So we look at all of those. We ask all the right questions to figure out what you qualify for. And we provide you an upfront instant quote. So you've gone through, it's usually about a 2-minute process, essentially. Address, we'll ask you any questions we need to confirm all those details about incentives. We design the system for your home, calculate the quote for you, and you have an upfront price for the system. Once that happens, we then ask for 2 photos to confirm that quote and finalize it. Those photos are, one, your electrical panel. So from that, we do a load calculation automatically to determine capacity of your home. And then number 2, your existing furnace system. And so from that, we just confirm our new system will fit, ductwork, and things like that. But from those couple of photos and that online quote, you have a firm price for your system that's guaranteed. So there's no in-home visit required. We don't have to come and measure if you're using 17 feet of line set or 21 feet or whatever. It is a flat price system that's upfront. Typically, our price is 30 to 50% below comparable legacy contractors for that system. Once you go ahead, we take a small deposit, usually $500 or $1,000, depending on where you are, and we schedule your install date. On the install date, our Jetson teams will show up in an all-electric, bright green Jetson van. Our teams are fully self-contained. So we have our own electricians in-house, HVAC technicians, everyone required to do this. It's a very orchestrated process. They show up first thing in the morning, walk the homeowner through exactly what's happening on site, where the outdoor unit's going, the plan, how it's all going to work. Then they start work. And so they'll disconnect the gas line, remove the furnace that's there, install our new central air handler. So that's a unit that replaces your existing furnace, and it's what blows the air through existing vents in the home to heat and cool the home. They install the outdoor unit, new electrical lines to both of those. They connect it. Then we go through a very detailed digital commissioning process that's also unique to Jetson. So a huge part of the performance of a heat pump system comes to it actually being set up properly for the home. So that's the refrigerants charged properly. We've confirmed the airflow of the system, how it's operating, essentially that it's fine-tuned for that home. So we go through a process to fine-tune that system and confirm it's operating as expected in the home. And then by dinner time or late afternoon, we're showing the homeowner how to use the Jetson app. We've installed their new smart thermostat system, walking them through their new heat pump system, and they're converted. That's it. End of day, they're on an all electric system in the home. So just basically to summarize, it's 2-minute online quote, couple photos, and single day install. Just making that really, really easy for homeowners to make that upgrade.
Yeah. Which is, I think if you look at that list of things you just walked through, like each of those is a friction point for a homeowner, from figuring out what size to like the ductwork in their house to the rebates. Like there's so much in there that otherwise would be a homeowner and maybe their contractor trying to like navigate all this stuff. There's a lot of complexity you're bringing together. What specifically needs to come together to make this like same day install happen? Because that's a lot of moving parts, a lot of data. It sounds like you're leaning on.
Yeah, there's a ton there.
Yeah.
That's what we have spent, and we've now done, well over 1,000 homes, and it's a lot of experience getting there. Where to start? So the first part I'd say is how we design the system, and this is one of the common flaws we see with more traditional contractors doing heat pumps that are not as specialized in the area. Is sizing a heat pump system is really important, and you want to size it so you have the right system that meets the heating and cooling needs of the home, but is not oversized. When you go to an
Okay.
oversized system, typically you have lower efficiency, lower performance, also a lot higher noise. It needs to move more air in the home when it's running. And so you want to match the system really well to the home. And the way that's traditionally done, probably in majority of the cases, unfortunately, is like a rule of thumb. Contractor will come in and say, oh, well, the furnace was this big, I'll just put in a similar size, or it's the home's about 2,000 square feet, so I'll do this, which is just the complete wrong way to do it. The sort of slightly better way is contracts will do what's called a F280 in Canada or Manual J in the US. They're similar approach, but where you calculate the heat load, and that's definitely kind of the current best practice is to do that. So you're going to go and figure out how big the home is, the type of insulation it has, the doors and windows, things like that, and you calculate how much heating and cooling it needs. That's a fairly good approach in general. On paper, it is. One of the challenges is that the way those are done in practice by most contractors, we review hundreds or thousands of these reports, is that they often still overestimate the heat load by a huge amount. There's just huge inconsistencies in how they're actually done. They can be quite inaccurate. And so where you often end up is still a system that's probably too big for the home in many cases and not optimal. And so the approach we've taken is more of a building science approach, where we're actually modeling that home and using a ton of data from thousands of homes we've evaluated and closed loop data. So we have models of the home. We're predicting the heat load throughout the entire year. But then we have systems we install. Every system we install is fully monitored by us. So we can actually real time see how much heating and cooling is being consumed. What is the weather outside?
Right.
Basically validate that model. So we have this closed loop data set that lets us produce a very accurate heat calculation. So that's kind of part one. Is we have a whole team spending a lot of time on how do we make sure we're getting that customer the right system for the home. Once that happens, there's sort of the process from we sized the customer, we've presented the quote for the system, they're happy with that. There may be rebates and other rebates, permit filings, et cetera, we need to do. So we've invested a lot in making those as easy as possible and trying to automate parts of that for the homeowner. So pre-filling forms, everything we can submit on their behalf, we'll take care of. The ones that they may have to submit some information directly, we have a team that will help guide them through exactly what's required. So it's really
Cool.
making that pre-install process just as streamlined as possible. And then on the actual install day, there's, in our case, we're doing the same system. Basically, we're doing a heat pump system, our Jetson system, in very high volumes across the country every single day. So we have dozens and dozens of these happening daily, right? We're installing the same system. And that's allowed us to make much larger investments in the tooling, the supply chain, the training, all of the pieces that make that go really smoothly. So when we first started, that install on day one might have been a 3-day install on average, where we'd come back, there were multiple steps, everything took a bit longer. And we just invested in, as you would in a mass production environment, if you think about building the first prototype iPhone versus the millionth iPhone, there's incredible learnings about how you make every step more efficient, eliminate waste, eliminate excess, materials, all sorts of things. We do the exact same with that heat pump process. And so we have our own infrastructure. So that's the supply chain and warehousing and everything else that's built just for this. We have a whole system on the trucks we use. From, you could imagine, like in a production environment, you have like color coded, kits of parts where every single part is required. So the technician working on the outdoor unit, they go to the site and they have every single one of the 250 parts they're going to use, from the brackets and connectors to angles to bolts to nuts to everything else. There's over 1,000 materials, pieces of sort of different items that go into a heat pump install. That includes everything from the wires and breakers to line set covers to insulation, et cetera. All of that is in a streamlined kind of back-end production process that results in a van showing up at your door, at 8 a.m, consistently every day, with every single one of those items there. on the van. And
Got
then when
it.
it comes to the actual installation part of that, we have a whole training program, obviously a Jetson University program called JetStart, that our technicians, who are typically very experienced folks from the industry that we hire, but we put them through this whole program to train specifically on the cold climate heat pump installations. What we found, from our earlier operations was that even the most experienced technicians often just haven't had as much exposure to heat pumps as they have other systems like gas and boilers and so on, furnaces. And there is a lot of nuance to doing a heat pump really, really well. And we have a very specific way to ensure the quality that we expect and everything else what we want to install our systems. And so we put everyone through a quite rigorous training program now that goes through every aspect of that install on site. So when they're coming on site, they've done this now hundreds of times. Typically, they've gone through the university training program from us for it. They have every tool, part, etc., required, and it's a very orchestrated kind of production-like environment where we can reliably and consistently at very high quality do this every single day. And that's very unique for us because we exclusively focus on whole home heat pump systems. And so
Right.
in the industry, what's more normal is sort of the opposite of that. It's very much a different thing every day. Maybe you're fixing, a plumbing problem or a boiler one day, you're installing a new furnace the next, maybe you're doing one brand of heat pump this day. And there's just a ton of inefficiency that comes from that versus we are very much, this is an orchestrated, choreographed team of people that work together every day. And this is what they specialize in and do every day. And we've just become extremely good at that process.
Yeah, that's super interesting. It's almost like the manufacturing approach. Like if you're doing everything by hand, unique every time, versus kind of that structured and like mass produced kind of approach. Was there a specific insight, like when you were kind of first digging into this area? Was there a specific insight that really unlocked like why the business has to be this way? Because I've seen some companies are like, we're going to build just the physical heat pump, and others are, we're going to do the coordination but rely on local contractors. Like where does this vertical integration insight kind of come from?
Yeah, it comes back to those two key things I mentioned at the beginning, which is for adoption here to get to where we think it should be, which is, the vast majority of homeowners are choosing all electric systems for their next replacement or for their upgrade. We've got to drive down the cost and the complexity. We just need to make it a no-brainer, obvious yes for every homeowner to pick this solution. And the cost has got to reflect that as well. And so as we think about that, the only model we could get to that would allow us to really drive both of those to the level we think they need to reach over time was through this vertical integration. There had been a number of other approaches in the industry before. We saw companies that were basically like sales platforms for heat pumps or home upgrades, where they would kind of have a nice website flow that was easier to understand the pricing and quote. But then they'd push it through basically to a subcontracted normal installer who would install a traditional heat pump. And they effectively became like additional margin sitting on top of the existing contractor. Like you're adding costs. You're now another player in the middle of that chain. So there's that side. There's on the equipment side, the traditional industry today it's quite inefficient. You have a handful of manufacturers make most of the heat pumps that are produced. They're often sold to a company like Carrier, who would then buy it, rebrand it, who sells it to a distributor, who sells it to the HVAC company, and then sells it to the homeowner. So you have 4 layers of margin stacking that happen on the supply chain as well. And there's other pieces to it, but effectively we just look at every amount of inefficiency from the first time a customer is interested in upgrading their home to that unit being installed to the ongoing operations of it. How do we just every day drive out some of that inefficiency that's there, which ultimately brings the cost down for homeowners, which means more homeowners choose all electric systems, which means lower emissions, and it's a whole cycle. So we think about, we need to optimize that entire flow and do so, I think, while really challenging the assumptions in the industry around what the customer experience has to be. I think if you were to bring on many or most traditional contractors on here and ask them about our approach, they would probably throw up all of the traditional like reasons why it can't be done this way.
Sure.
We need to be in the home because maybe this home is a little different. I might need a different path to route the wires. There's just like a million. If you come from the mindset of like how things are done today, it's very easy to have all these roadblocks to get there. And we really just said we need to make this something that's a consumer centric approach, really easy for homeowners, and we've got to rethink the current status quo to do that. And we think as a result, you can deliver a much better product at a way higher quality level and ultimately at a much better price point for the homeowner. And
Yeah.
that's all kind of on the upfront portion. We didn't really talk about yet, but the level sort of layer two of the business is once that system is installed, it's not just another heat pump. Like we can talk more about that, but we've
Yeah. Yeah.
really applied that consumer product and software background to making the product itself better. I think in the same way that we saw with EVs, right? The
Mm,
successful EV manufacturers didn't just take an internal combustion car and put an electric motor in it and call it a day. They rethought the product with the new technology and software that was available to make the product experience better. We're
yeah.
trying to do the same thing for the home.
Yeah, I'd love to chat about that more. One on the installation side. So, like, I live in an older home with a bunch of quirks and weirdness. And you were mentioning like contractors, they see all this stuff, and I'm sure their perspective is often like, you have to go see the thing. There's all these, unique snowflake cases. How do you solve for some of those like one-off problems, panel upgrades, tight spaces, ductwork, all that kind of stuff?
Yeah, like every home is a little bit unique, and I think it's easy to sort of stop there and say, well, if they're all unique, then we just have to do a bespoke
Right.
solution for every home. We solve that in two ways. So the in general, the approach we take is most of what you would learn, and if let's say we came and visited your home, and yeah, it's an older home, and there's something bespoke about it. Most of what you would learn is what I'm going to take away from that. So I did the walkthrough. I might take away that okay, well, I need maybe some different materials with me. I need some different line covers to cover this corner I'm going around, a different drill bit to get through the brick, whatever it is. I need something different. In general, we've gone through and said, in every case like that, let's figure out how we can incorporate that difference into our standard kit of parts, training process so
Oh,
that
interesting.
when we show up on site, we're prepared for all those eventualities. We're prepared for that this house might have a much longer run and we have to go through the attic and run 100 feet of line set instead of 25 feet for this other house. We're prepared for the fact that, this house might be stone or brick versus siding. We're prepared for that the clearance might be tight. So we've essentially built our process and training and tools and then the supplies we have ready to account for all of those differences. And now having done this for thousands of homes, we've iteratively over time basically solved all of the edge cases there. So when we get to a home today, like there is effectively no home we get to where we can't complete that install in the day,
Mm,
because we've generally done that. And the second piece is we are still doing a bunch of pre-work. So it's not visiting the home necessarily and taking your time as the homeowner, but from the photos we're reviewing, we're sort of selectively looking at the right cases there. We have other information we look at internally. And there are a set of homes, like maybe it's 5% of homes that we choose to go and do some additional review of. And in those cases, we might ask for a video call with the homeowner to check something before the install date. Or in a smaller set, we may actually do an in-person walkthrough. And
mm,
those are ones that there's something atypical that we have now enough knowledge of the process to sort of pick up on the ones that need some extra attention there. But for the vast majority of homes, we've accounted for the variance really in the way we think about the materials, the training, the process that we use. And there's actually far more in common than there is really different for most homes.
yeah, that's super interesting to look at. How do you bring these into your standard operating procedure rather than treat them as their own unique snowflake variances? And I'd imagine that probably takes your one-offs from like 15% to like 1 or 2%, which just dramatically changes the complexity you're trying to deal with.
Exactly. Yeah.
Yeah. I'd love to talk about the post install and that feedback loop. I think that's super interesting where this device in your house now isn't just like sitting there operating kind of dumb to the world, but there's this new feedback loop you've introduced.
Yeah. So there's just as a baseline, there's a few different things about the hardware we install. The heat pump we install, like the mechanical parts of it, so the compressors and the fans and the refrigerant loops and everything else, they are effectively, very similar to the next best high-end cold climate heat pump unit. So it's, we have amongst the highest efficiency numbers, the highest Energy Star ratings, et cetera. There's not significant changes on like the basic mechanical parts of that. Where our system gets more unique is on the controls, electronics, sensors that are part of our systems. So
Mm.
the Jetson heat pump system, it's a cold climate central ducted heat pump. So it works down to minus 30 Celsius, minus 22 Fahrenheit. It replaces the furnace and air handler. So we have an indoor unit and an outdoor unit that connect together. We have a smart system that's part of that. So that smart system is number one, an air quality monitoring system. And so we actually can monitor from that heat pump the home's air quality in a very detailed way, meaning the CO2 levels, PM 2.5, PM5 is particulate matter in the air,
Right.
VOCs, et cetera. So we have it's an industrial grade home energy monitoring system that's built in
Hmm.
as part of that. Our home air quality monitoring system. We have energy monitoring. So in your main panel, we actually monitor the entire home's energy use in addition to the heat pump system. So we install that in every home we install. All of that technology is connected back to our Jetson hub, which is our core kind of brains of the system that's coordinating the heat pump, all of the sensor systems, and our Jetson smart thermostat. That all connects back to us. And so we're able to then remotely monitor how our systems are performing, meaning we can tell actually much more than you would know as a technician being in the home. So a typical,
Hmm.
let's say you have a problem with the heat pump, at some point you might call a technician in, they're going to hook up some gauges and probes and try and figure out what's going on. We have all of that and then about 200 other data points. So very deep
Wow.
telematics of our systems that are useful for a number of things. One, they can help us remotely diagnose any issues. One of the biggest reasons for service calls for heat pumps in the industry, something like 40% of service calls, the root cause ends up being a dirty air filter, which is
No way.
it
Yeah.
seems crazy, but it
Yeah.
manifests in lots of ways. Once your airflow is blocked, you can get high pressure triggers and all sorts of things can happen. And so a huge percentage of those service calls, and that would typically for a homeowner, that might be a $300 call out of a technician to come
Yeah.
to your
Yeah.
home and ultimately find, oh shoot, the filter was dirty, right? And so really basic example, but we can detect that remotely and let the customer know, to address that. Maybe there's a more substantial issue, like there's a slow leak of refrigerant that over time could have become a big repair bill if your compressor went or something. Because we can detect those preemptively, we can actually let the customer know in advance. They may not even have realized there's an issue yet with their system, and we can preemptively just say technician's going to drop by and address this. And so we actually avoid like a no heat in the middle of the winter or a much bigger repair bill by monitoring the systems. That's the basics there. The next piece is that there's huge opportunities to optimize the cost of that system and the energy use in the home. And that's a big reason we've invested in all this connectivity, is that once that's installed, the traditional model today is if I put in a heating system, it's basically a disconnected dumb box in your attic or crawl space for the next
Yeah.
10, 15, 20 years. You have no idea how it's performing. You don't know if it's been degraded for efficiency and you're wasting money every month on your bills. It doesn't get better over time. There's no changes to like the controls and software on it. If you think of a modern EV, it's the opposite, right? You purchase the car, but there's continual process of monitoring and updates, and that product gets better over time. We've done the same thing for the home, and so we can continue to upgrade the performance and the software on those units. And we're regularly releasing updates that improve the performance of that system. But one of the areas we're really excited about is there's a huge opportunity to really optimize throughout the day how and when the system uses energy to make it the most economical for that
Oh,
homeowner.
okay. Yeah.
So if we think about it depends on where you are today, but different utilities have various rate structures. So you may have time of use rates that are applicable. I think you're in Ontario, so I believe most areas of Ontario have some time of use rates.
Hmm.
But it may be significantly cheaper, let's say, to draw energy at certain periods throughout the day and more expensive during peak periods. And so because we have this detailed software and modeling of your whole home, we understand the heat loss of the home, we understand the weather patterns, we know exactly like how much the comfort of the home will change based on different inputs from your heating system. We can run this software effectively that's going to say, hey, what if for Justin's home, it's all happening automatically, we just shifted your heating to a little earlier in the day. And so we're going to heat it up, a degree over the set point or a degree and a half or something, a couple hours earlier. And that might save you 10% or 15% monthly in your energy
Hmm.
costs because we're avoiding those peak periods. And you can get much deeper than that and think about actually working with utilities and trying to reduce those costs for homeowners, which we're doing a lot of work there. But it's ultimately the model we have to think about is how do we make the home as comfortable as possible for the homeowner while also reducing their costs every month to
Yeah.
achieve
Yeah.
that comfort. And so there's a whole ton of work happening in the sort of background on the energy side there to think about optimizing that as well.
Yeah. The grid interaction I think is very interesting, and this idea of like you could have this fleet of like millions of units out there responding to what the grid needs and playing into some of these demand response programs. Those also seem to be growing everywhere, basically, as the grid kind of hits more constraints. So it makes a lot of sense to be able to kind of plug into that.
Yeah, and I think you can go a lot further than traditional demand response. So traditional demand response is like you get a signal to say turn off your AC or your heating or turn it down during a peak
Mm,
time for the grid. Um, where this gets more interesting is because our system is fully connected, and we have this sort of fleet view and predictive view of what's happening. Instead of doing that, which might actually impact the comfort of your home, what we would much rather do is work with utilities and say, how do we work to ensure we can maintain the comfort in the home, but just play with very subtly throughout the day how we're drawing power on the system to shape that profile to match when power is available. So,
Oh,
when solar
interesting.
is available middle of the day and power is cheaper, let's use more of your energy to heat your hot water tank, to heat or cool the home then, and let's use slightly less later. So instead of the traditional like, oh shoot, we're overloaded, let's just
Yeah,
turn
yeah.
off the AC, I think it's a much smarter approach to think about, let's proactively manage the home and figure out ways to optimize energy use for both the grid and the homeowner in that way.
I'd love to just talk about some of the other barriers out there. Like we've talked a bit about cost and some of these friction points, but it seems like there's a lot of both behavior and like misconceptions out there still. So I'd love to get from your perspective, like what are some of those, maybe like outdated perspectives or common barriers that you're still running into in the field and still hearing from homeowners?
Yeah, this one's near and dear to my heart, 'cause we have these conversations all the
Right.
time. And unfortunately, there are a lot of misconceptions. It's very regional, we find. So
Hmm.
areas that have higher heat pump deployment, there's far less of these, just because it's more normalized. Like people know their neighbor that had a heat pump installed, and it was great. Like they've have
Yeah,
those
yeah.
stories, versus areas where the penetration is lower. There's still a lot of this sort of kind of fear almost that exists, and just inaccurate information. And I think a lot of this comes from the traditional base of contractors, and not necessarily maliciously, just the experience is largely in gas systems. And I think there were things that might have been true 10 years ago that have kind of persisted as like myths today that don't apply. So one of those would be like cold climate performance. We hear this all the time.
Yeah.
And we hear it even in climates like here in the BC lower mainland, which is, it doesn't even get to freezing here. Like there's
Yeah, yeah.
basically not snow. That is, it's the easiest climate probably in all of Canada for heat pumps. But we hear things like, oh, it's too cold here, they don't work in the cold, all the time. And the reality is a modern cold climate system like Jetson Air works to minus 30 Celsius. It works in the coldest areas of the
Yeah.
States, and for essentially all of populated Canada
And is
today. So
that
we hear
like
things.
it works and doesn't work, or it like becomes slightly less efficient? Because I feel like that's another aspect of like, oh, it's going to shut off at minus 30 or something.
Yeah, the systems are rated through minus 30. They can
Okay.
often perform through that. That's sort of the end of the rated range. Now, there's few areas in Canada, large populated areas, where your design temperature is actually below minus 30.
Mm,
But in those situations, you just add a backup heat strip, which might run for a very small number of hours per year, which has no minimum temperature.
right.
But for the vast majority of places, like in Ottawa, your heat strip will likely never run.
Yeah, yeah.
Because it's yeah, so that you effectively have no real limit there. But in somewhere like we install in Colorado and the Northeast in Massachusetts, where you actually have regular temperatures that are minus 20 Celsius, minus 25 Celsius, and these systems perform flawlessly through there, and have for a decade now of these systems being out. But that misconception still exists. We hear folks like below freezing, below 5 degrees, like they're hugely inefficient. It's going to triple your
Right.
costs. The reality is, the areas at least that we install in, you're a high-end cold climate heat pump system like Jetson Air is typically the lowest cost way to heat your home. Or if it's not, it's very close, like within plus or minus 5 or 10% from like the most efficient gas system. There's nowhere we install where it's more expensive to heat with a heat pump system by any significant amount. And for most homeowners switching from an existing older system, they're typically saving money on their annual heating costs. Like our
Right,
typical
right.
saving is something like 20% coming from a gas system, more coming from oil. So it is hugely economical for the homeowner as well. So that's another misconception we hear. I think a lot of the confusion there comes from it being electric heat. We hear this one all the time. Oh, I've heard electric heat is like 3 times more expensive than using my
Right.
furnace. And that might be true if you were talking about baseboard, like resistive electric heat. So that might be 3 times more. The heat pump is 3.5 times more efficient than that baseboard heat, and
Yeah.
so it actually ends up being similar, often lower cost than the most efficient gas systems. And
Hmm.
so also not something we hear this one all the time, that they're noisy.
Hmm.
The outdoor units can be noisy. Again, just not true with current generation of units. Jetson Air is a fully variable speed unit. The outside unit is like whisper quiet. You and I can have a conversation 3 feet away from it, and it's gentle air movement, but it's not not a noise issue at all anymore. That's an outdated thing. I'm trying to think what else. We hear lots of these kind of
Yeah.
lingering things, but as soon as we're in an area where a number of folks, like the higher penetration of heat pumps, these basically go away because everyone has just seen this, and instead of
Mhm.
being this kind of new unknown thing, it's like, oh yeah, three of my neighbors have them, they love them, they work great. Like,
Totally.
they stayed warm on that cold spell last winter, and once you have that, then it's much easier, I think, for folks to realize.
Yeah, that makes sense. And I think for folks, like it's often just this unknown, and to take a leap into the unknown is like, particularly with something like your home heating, like you don't necessarily want to like roll the dice on that. You mentioned, so you're in Vancouver, Colorado, Massachusetts. How do you think about market entry, and like is there a minimum set of conditions that needs to be true for you to like enter a market?
Yeah, we're less marketed or less limited today on markets we could enter, and more just on, practically we're growing very fast. We're opening up these
Yeah.
new markets. There's a whole set of work we have to do for everyone, so we want to make sure we do that properly and enter them at a pace we can sustain. We are entering a number of markets over the next little bit, so we'll be in California very shortly here, with several locations opening in California. As we think about the locations where we prioritize, it's typically areas that have a high penetration of existing central ducted homes today. So that is, most major areas, but we're mostly targeting single family homes, townhomes, semi-detached homes. So versus like high rise homes, it's mostly lower density housing that has that furnace system today, which is most of that emissions profile. So we're targeting areas like that. We look at the relative costs of fuel for the market we're in. So what is electricity versus the gas or oil prices, depending what's dominant there. Prioritize that. And then just the political climate as well. Generally,
Mm,
areas that are more oriented to electrification, are faster adopters of the technologies. That's one of the factors we look at. And there's several others, but we've kind of prioritized markets based on that. We'd like to be in as many as we can as quickly as
yeah.
possible. We get requests from homeowners all over the place that would love to have a system upgraded, and so we're working hard to be in as many as we can, but at the same time balancing the right sort of methodical, scalable way to do that, one
For
by one.
sure. Yeah. Do government rebates play a significant role in that decision? Because I feel like that's what a lot of companies have really relied on to make their systems work. But it sounds like that's not as big of a factor in how you're approaching this.
Yeah, it is a factor for sure. 'Cause I think we think of these incentive programs as a huge accelerant to adoption,
Mm,
especially when current adoption levels in area are low. So, getting the first like 20% of homes to a
okay.
heat pump system, and getting the proof points for, like we said, talked earlier, your neighbors and other folks having done this, it creates the inertia and the knowledge, and sort of it gets the market moving. So I think we saw that with EVs, right? Like once in Canada federally, we had that EV tax credit. Initially, I think it was like a $5,000 credit.
Yeah.
I
Yeah.
think that actually was hugely beneficial in speeding up adoption of EVs, because it got that first cohort of people driving them. And then suddenly you had like a friend that had driven whatever it was, a Tesla or an EV, and kind of realized, oh, actually, yeah, they do work in the cold in Canada, and they're,
Yeah. Yeah.
all the benefits. And so I think those programs are very beneficial. Also beneficial from the perspective of every home that makes that choice to go to another gas system, that's another 15 years roughly of emission. Your average lifespan of a furnace is about 15 years. And so
Right.
something that we think about a lot and probably, lose sleep on, is like every time we have a homeowner choose that replacing their old system with another gas system is like another 15 years of being locked in. So it's a
Yeah.
long
Yeah.
cycle. And so I think these incentive programs are hugely beneficial to make that choice a more obvious choice for them to say, I'm going to choose the all electric, better performing, cleaner system. So yeah, we definitely look at that. I think they're a big accelerant to these markets. They won't
Yeah.
exist forever, just like with EVs, but I think they're very beneficial in helping get to that critical mass to
Yeah.
start the industry.
That makes a lot of sense. So as you're mentioning entering all these markets in like a scalable, sustainable way, how do you think about the labor aspect of this? Because you need like trained technicians, electricians, all this kind of stuff. Maybe like, yeah, how are you thinking about that? And any like lessons learned from some of those like first markets you entered?
Yeah, we think about the team in two ways. There's a core team that's building a lot of the pieces behind the scenes on this. So that's the
Right.
the infrastructure for the heat pumps, the engineering, the software, the operations organizations that do the design, manufacture, supply chain, everything else. There's a lot of technology kind of behind the scenes that make the price point and the ease and everything possible. What seems simple for the homeowner is often, a lot of work we've taken on the back end. So on that side, we have just an incredible level of talent density. So we've hired a lot of the folks that the other founders and I worked with previously at, our former company at Google, and then just key operational folks from companies like Tesla and Sunrun and some of the largest leaders in this space. So we have a huge backbench of talent on the operations and field operations side, that have run very large scale organizations here. And then on the field side, we've invested a ton in training. And I mentioned earlier, we have this Jetson University program called JetStart. We are typically recruiting apprentices, electricians, HVAC technicians that are licensed in the areas we're operating in. Very selective in the recruiting process, but we have this, I think, unique benefit in a very tight labor market where it's a very different proposition, I think, for a lot of those technicians. That we're often self-selecting for folks that are interested in electrification and want to work on sort of a mission-driven company and
Okay.
are really excited about getting homes to more modern technology, getting them electrified off of fossil fuels. And so that's just a very different proposition, different style of working, different culture than a traditional installer in those markets. So I think that helps us from a recruiting perspective
For sure.
quite a lot, for sure. And then, yeah, we put everyone through that training process and we continue to develop, more tools there. But we've been fortunate that we've been able to attract just extremely talented folks at all parts of that organization, from more of the back office and supply chain and warehouse, but right through to all of our field operations, which is our electricians, HVAC technicians, and so on.
And then I guess last question is like, if you're thinking ahead, like maybe 5 years, what does Jetson look like, and what does the world of home electrification look like?
Yeah, I'm hopeful that one of the things we can do here, so we're obviously focused on the homes we directly electrify. So every customer of Jetson, our homeowners, is a big focus. But I think more broadly on the industry, I hope that we can be a little bit of a instigator to force. We're not going to do it alone. There's going to be many players that have an impact on this market, and many of the traditional home services businesses here, I think, are going to kind of come along and be a huge part of that transition. So we're hoping we can help move the whole industry forward in really increasing the uptake of all electric systems, the quality and the sort of methodical install and design process that we're bringing to the industry. And ultimately, end of the day, the main metric is how do we get more homes making that choice of choosing an all electric system. So really excited about that. And then, yeah, we just think a lot about the heating system is one of the most significant choices you can make. It's about 75% of your home's energy use. There's other parts of that electric future for homeowners that we want to make as seamless as we have for heating. So we just think about that full set of products in the home that should be working together really seamlessly to make your home perform really well, be as smart as possible and as efficient as possible.
Perfect. Well, I think that's a great place to leave it. For folks listening, any final ask or place where people can go to learn more?
Yeah, you can learn more at jetsonhome.com. If you're in one of the markets that we're currently in, definitely you can check out your home on there and see what a system would look like. And for others, we're working hard to be in more areas soon. So stay tuned.
Perfect. Stephen, thanks so much for your time. Really appreciate it.
Yeah, thanks a lot, Justin.